Hello, beautiful people, and welcome. This is part 3 to your pre-test, all things logarithms. We're going to go ahead and jump right in. Again, we are on campus, so if you hear the intercom or a loud bell, I apologize in advance. Also, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I can fix my mistake and we can both learn from my mistakes so you don't have to make them yourself. All right, let's get started. Number 26. These are application problems. So the pH is given by the formula. Here's your formula. Anytime I have word problems, I'm gonna underline, circle, highlight, just to have that information stand out. It's just something that I've grown accustomed to doing. Where H plus, I used to remember what that's called. I don't know. Is the concentration of hydrogen in moles per liter. Okay. If the pH of Bill's swimming pool is 7.8, that seems important. So pH of Bill's swimming pool is 7.8, and the pH of Mara's swimming pool is 7.2. Whose pool has a greater concentration of hydrogen? Okay, so they say here's the concentration of hydrogen. There it is. And so what's the question? What is it asking us? It's asking us whose pool is greater concentration. And so here's question number 1, and here's question number 2. And how many times is it greater? All right, let's solve this. Let me put my marker away, grab my pencil, just in case. I have a feeling there might be some erasing in this, and that's okay. All right, here's our formula. pH is equal to negative log times our hydrogen concentration. That's what I'm going to call it. Okay, so now we have two things to compare. I have Bill and I have Mara. Okay, so Bill has a pH, a total pH of 7.8, and it's being asked what the hydrogen concentration is. Mara has a pH of 7.2, and again, it's being asked what the hydrogen concentration of that is. Now, I knew there was going to be an eraser involved. I'm actually going to take my H away and just put in a random X. I'm so used to X and Y's that just seeing that H gives me anxiety, so I'm going to remove it and just change the variable. And I'm okay if you do that, as long as you know that in the end, the X also represents the concentration of hydrogen. I'm okay with that. All right, so we're trying to find here, anytime it doesn't provide a base for you in a log, that means we have base 10. So I'm going to convert this to exponential form. So I have a base of 10. My exponent is 7.8 is equal to x. So I'm going to rewrite this one just to show you. Oh, you know what? I'm going to need to use that eraser again. I didn't realize that it was a negative out in front. So I'm going to change that. I'm going to change that. And you'll see why. You'll see why. Okay. You see that negative out in front? That negative out in front says that you have a value, or you have a value of -1 out in front. That's -1 times your log base 10. So this is -1 times your log base 10 of x, which is equal to 7.8. So what I'm going to do is I'm going to divide by -1 on both sides. So what I'm going to have is log base 10 of x is equal to -7.8. And again, I'm going to rewrite this. Log base 10 of x is equal to -7.2. All right. And then we're going to rewrite this. So I have base 10, -7.8 is equal to 8, x. So base 10, and again, we're going counterclockwise. So 10 is your base, exponent is -7.2, and that's equal to your x. And so I don't know what that is on a calculator. I mean, I can always figure it out. So 10 to the power of negative 7.8. Sorry, my calculator is telling me syntax. So I don't know why that's doing that. It's telling me there's an error. Let me see what that is. 10 to the power of negative 7.8. There it goes. So I'm not going to write that. I'm going to keep it in exact form. And I'll show you why. Because, I mean, we're solving for X. We're solving for the concentration of hydrogen. I changed my H right here to an X just to make it easier for me. But if I plug it into the calculator, let me show you guys, this is what it becomes. 1.58489, 1.58489. And that's going to be for Bill. So I don't want to do that. But it's asking how many times greater is it? So question number 1. It says, whose pool has a greater concentration? I guess we do maybe need to see what Mara's concentration is. So Bill, we're looking at approximately 1.85. And Mara, we're looking at approximately 6.3. So who has a greater concentration? Mara. And then how many times? So what I'm going to do is I'm going to actually 1.58 divided by 6.3. Oops. So I'm going to do to find out question number 2. I'm going to say I have about 6.3 and I'm going to say 1.58. So that's about 3.98. So about 4 times greater. So here's answer to question number 2, answer number 1. And all of this work is to answer question number 1. Okay. Let's go ahead and move on to number 27. Seismologists use the Richards scale to express the magnitude M. So M is the magnitude of an earthquake using the formula. I'm pretty sure this is going to be important. Where E is the energy in ergs. E is in ergs. Use the information for problems number 16 and 17. Okay. I'm assuming this is 16 and I'm assuming this is 17. In 2007, the earthquake in Sumatra, Indonesia, released 3.55 times 10 to the 27 ergs of energy. So I'm looking back here. I know this is going to be my E value. What is the earthquake's magnitude? I need to know what the magnitude is. So I'm solving for M on the Richards scale. Okay, so let's go ahead and write our formula down. So magnitude is equal to 2/3 times our log of E divided by 10 to the 11.8. Okay, let me go ahead and erase my E because I know what that is. That is 3.55 times 10 to the 24th power. And I'm doing that on my calculator. I'm typing parenthesis 3.55. Actually, I might even take that back. Because it doesn't have a base here, I know this is base 10. And because it is base 10, my calculator can do all the work. So I am actually typing in log times parenthesis 3.55 times 10 to the 24th power, parenthesis, divided by parenthesis 10 to the power of 11.8, parenthesis, parenthesis. Let me see if I can show you guys what I did. Let me scroll back. Again, this is we're able to do that because we have a log of base 10. How do we know it's base 10? It's not there. If you have a log that doesn't have a base indicated, it's always base 10. So I'm typing in log of 3.55 times 10 to the 24th. That whole thing is in parentheses. I'm going to divide it by 10 to the power of 11.8. That second part is in parentheses too, because you need to tell the calculator that we're dividing by all of this. And then I'm enclosing it at the end because we're taking the log of all of that. I'm pressing enter. So it gives me about 12.7502. And then I'm not done because I still need to multiply by 2/3. So that gives me a magnitude of 8.5-ish. It doesn't say anything, so I'm just going to let it equal m. M is the magnitude. So 8.5 in magnitude. Okay, in 1960, an earthquake in Valdivia? I'm just great at names, you guys, in this video. Jeez. So Valdivia, Chile, measured 9.5 on the Richter scale. So if it measured, that means this is our, we're going back to here, if it's expressing the magnitude on the Richter scale, that means this is our magnitude. What is the energy? Energy we said is capital E in ergs by the earthquake of this magnitude. Okay, so that means I'm going to work here. So we know that is 9.5 in magnitude. We still have our formula. I'm actually going to write in the base 10. So then we don't know what E is. Okay, so this here is in a bubble. Okay, whatever your log of something that is in a bubble, do not just split it up. You can't do that. The only way that you can do that is through a property or a definition. Okay, what I can do is I'm noticing that this is 2/3 times log base 10. So I'm going to actually multiply by the reciprocal. I'm going to multiply it by 3/2 on both sides. And the reason for that is I want to get rid of my 2's and I want to get rid of my 3. So then I have on my right hand side just my log base 10 of E divided by 10 to the power of 11.8. And this I have is 9.5 times 3 divided by 2. Oh, excuse me. Oh, excuse me. Allergies, Jesus. Okay. All right. Sorry about that. So we have 9.5 times 3 divided by 2, and that gives me a 14.25. This is where I'm going to use the definition of a logarithm. So I'm rewriting it as an exponential function. So I have 10. Again, we're going counterclockwise, but in this case, this 14.5 would be placed on my right-hand side. So then we have 10. Exponent is 14.25, and that's equal to E divided by 10 to the power of 11.8. So immediately I'm going to multiply by 10 to the power of 11.8 to get rid of that. And then my trusty calculator is going to do the hard work for me, so I'm doing 10 to the power of 11.8 times 10 to the power of 14.25. And that's going to give me a big number. So I'm going to 11.8 plus 14.25. So that gives me, I'm going to just add these. Do you notice how the base is the same? So whenever we're multiplying and the base is the same and the exponents, we can just add the exponents because the base is the same. Okay, so we can do 10 to the power of 26.05, and that's equal to E. If we wanted to approximate, my calculator is giving me a scientific number, which is 1.12 times 10 to the power of 26, which again, this should be it. All right, let's continue. Oh, that is B. So E is, I'm going to write the exact. So this is ergs. E-R-G-S, ergs. Because the energy is measured in ergs. All right, the final one is a bonus question. So this one here, I think everyone should be able to get this bonus question, but it is a little bit on the difficult side. So let me walk you through it. Okay, do you notice how we have 10 and 10 here? We have an x in our exponent. We have a 2x. This is where we're going to be using our u substitution. So I'm going to say let u be equal to this middle term here. So 10 to the x. Now, it's whatever this equals, whatever this is. So I have 10 to the x. we need to set it equal to u, and so we can factor. So I'm going to now have u. I know that 10 to the x is u. What do I have left over? I have a 2 left over here. So I have u squared minus, this no longer is 10 to the x. This is now u. And then before I get too far, I forgot to subtract 2 on both sides. So I have u squared minus u minus 2, and that's equal to 0. Now that we're here, I'm going to, let me move this paper. I'm going to either use diamond method or guess and check. I'm going to have u in each bubble, two numbers that multiply to -2, but when I add them, give me +1. I'm going to say this is -2, and I think I call this positive. It should be a negative. So multiply to -2, but add up to a -1. So this is -2 and +1. After you're here, you're going to resubstitute back in your 10 to the x. So I have 10 to the x minus 2, and I have 10 to the x plus 1. From here, you're going to set each bubble equal to 0 and solve. So I have 10 to the x minus 2 is equal to 0, and I have 10 to the x plus 1 is equal to 0. From here, I'm going to add 2 to both sides. So I have 10 to the x is equal to 2. 10 to the x is equal to, I don't know why I did plus 2 here, minus 1. Now I'm going to apply the definition of a logarithm. So log base 10 of 2 is equal to x, and this one log base 10 of -1 is equal to x. Now right away, you see this negative, log base 10 of a negative number. Can't take a logarithm of a negative number, so that no longer works, so we cross it out. So we're left here, log base 10 of 2. It is base 10, so that means our calculator can do the work for us. So I'm doing log of 2, and that gives me 0.301-ish. And then you get your bonus, and then you get bonus. All right, guys, that wraps up part 3. Now, there are some things that I do want to mention that you need to know for this upcoming test. You need to know all your properties. You need to know, oh, you can't even see that. Let me change my marker. You need to know all your properties. There you go. All your properties. You need to know that natural log is log base e. And you need to know that how to use that. You need to know the definition of a logarithm. You need to know that log base b of a is equal to x. If and only if b to the x is equal to a. You need to know how to go from one form to the other very fluently. You need to make sure there's no hiccups there. I think that's about it. I'm going to take a look at the other question. We need to rewrite things in exponential form, but this natural log, it wasn't covered in this pretest. All the properties were not covered in pretest. This we used so often in this pretest that you must know that. Inverses, there's a few examples in the pretest. Expanding, condensing, logarithms, solving equations, super important. Make sure that you remember your 2 reference points and your vertical asymptote. That's going to be on it. But make sure you know all your properties, your natural logs. There will be a question on that. Every single question on this pretest is good review. Please make sure that if you're struggling to watch videos on YouTube, to come in for lunch tutoring, after school tutoring with Rio. We're here at Rio Americana, so at Rio we have after school tutoring with different math teachers. Definitely ask me questions, and good luck, and I hope you all score 100% on your test.